When we do an experiment, we will be using various instruments to measure physical quantities. After getting various physical quantities, we will be doing various mathematical operations to get the final result. The error in the final result depends on two factors. First one is the errors in the individual measurements. Second one is on the nature of mathematical operations performed to get the final result. We will be using various mathematical operations: addition, subtraction, multiplication, division. Let us see one by one. First, I will explain addition of physical quantities. When we do mathematical operations, errors in the individual measurements will combine. This combination of errors is known as propagation of errors. First, let us see the mathematical operation of addition. Error in the sum of two quantities. A and B are two quantities. In the measurement of A, there is an error, delta A. In the measurement of B, the error is delta B. We are adding these two quantities to get Z. Error in Z is delta Z. Measured value of A is A plus or minus delta A. Delta A is the error in A, so measured value of A is A plus or minus delta A. Similarly, measured value of B is B plus or minus delta B. Now we have to find the error in Z. You consider this sum, Z is equal to A plus B. Now Z plus or minus delta Z, where delta Z is the error in the sum of the two quantities. That is equal to measured value of A is A plus or minus delta A. Measured value of B is B plus or minus delta B. Now we can combine this and this A plus B. Then plus or minus common, you take it outside. So here it will be delta A. This is taken outside. So here it is plus delta B. Now compare both sides. So you can see plus or minus. Then delta Z is equal to delta A plus delta B. So this is the error in the sum, delta Z. So error in the sum of two physical quantities is equal to the sum of the absolute errors in the individual quantities. Now let us see an example. R1 and R2 are two resistances connected in series. R1 is 100 plus or minus 3 ohm. So in the measurement of R1 there is an error of 3. In the measurement of R2 there is an error, that is 2. 150 plus or minus 2. When resistances are connected in series, its equivalent resistance is given by R is equal to R1 plus R2. R1 is 100 plus or minus 3. R2 is 150 plus or minus 2. So 100 plus 150, then this plus or minus you write outside, then 3 plus 2. So equivalent resistance is 250 plus or minus 5. So you can see in individual measurements or quantity there are errors of 3 and 2. But in the final answer there is an error of 5. That means the maximum possible error in the sum of two physical quantities is the sum of absolute errors in the individual quantities. In this there is an error of 3, in this there is an error of 2, in the final answer there is an error of 5. Now error in the difference of two quantities. A and B are two physical quantities. In the measurement of A, there is an error of delta A. In the measurement of B, there is an error of delta B. We have to find the difference between A and B. That means A minus B. The result is Z. The error in the final result is delta Z. Since there is an error of delta A in the measurement of A, measured value of A will be A plus or minus delta A. Similarly, the measured value of B is B plus or minus delta B. Now, Z is A minus B. Z is the difference between A and B, A minus B. Now, error in Z can be obtained from this. Z plus or minus delta Z is equal to measured value of A is A plus or minus delta A minus B plus or minus delta B, because Z is A minus B. So this is the measured value of A, this is the measured value of B. You subtract. Then A minus B, here you can see plus or minus, here also you can see plus or minus, so that can be taken outside. Then here there is a chance of confusion because outside it is negative. So now when you take this inside, this plus will become minus, this minus will become plus. So you can take a plus or minus outside, after that inside it will be plus. Now delta Z is delta A plus delta B. So this is the error in the final result. So maximum possible error in the difference of two quantities is equal to sum of the absolute errors in the individual quantities. Temperature of two bodies are given. Temperature of the first body is 20 plus or minus 0.5. There is an error of 0.5. Temperature of the second body T2 is 50 plus or minus 0.5. Now we have to find the temperature difference. T is equal to T2 minus T1. T2, you write this value. T1, you write this value. Now 50 minus 20. Then plus or minus 0.5. Here plus or minus 0.5. But outside there is a minus sign. So if you take a plus or minus outside, then there is a confusion whether to write minus inside. Error means maximum possible error. Suppose you take a minus here, 0.5 minus 0.5. So error will become 0. So that cannot happen. In the individual measurements, there are errors. So it will not get cancelled. So here it should not be minus, it should be plus or minus. Plus or minus. After taking this outside, don't put this minus inside. This plus will become minus, this minus will become plus. So plus or minus outside. So error means maximum possible error. So here we cannot take a minus. So 0.5 plus 0.5, so it's 1. So error will be the sum in the individual measurements. So maximum possible error in the difference of two quantities is equal to the sum of absolute errors in the individual measurements.